Good afternoon, students. Today I am going to start the second part of this very unit, that is differentiation. We have also started in the 11th class. Let me revise the previous result that we have done in the 11th class, means the derivative of the different function that we have to use in the further questions. Now here we know the derivative of sin x is cos x. This is the sign of derivative d by dx. Derivative of sin x is cos x. Then again the derivative of cos x is minus sin x. Derivative of tan x equal to secant square x. Then derivative of cot x equal to minus cosecant square x. Then derivative of secant x equal to secant x into tan x. Then the derivative of cosecant x equal to minus cosecant x into cot x. These are the derivative of 6 trigonometrical ratios. Now you can easily learn it. Now let me see the derivative of some more functions. Now the derivative of x raised to power n is equal to n into x raised to power n minus 1. Which one is the power? We can take it here. And then we will subtract 1 from the given power. So therefore the derivative of x raised to power n equal to n x raised to power n minus 1. Then the derivative of ax plus b whole power n. And it should be always the linear function. This function should always be linear. So the derivative of this, now first we have to take the whole power. Then the power will be here, n into ax plus b whole power n minus 1 into coefficient of x, See it again. The derivative of ax plus b whole power n equal to n into ax plus b whole power n minus 1 into coefficient of x, and it must be the linear function. Then the derivative of e raised to power x equal to e raised to power x. It will remain the same. Then the derivative of a raised to power x equal to a raised to power x into log a. Then the derivative of log x with the base e. This is pronounced as a logarithmic function. So therefore the derivative of log of x and base is e is any irrational number is equal to 1 upon x. See it again. Or simply we can write the derivative of log x. If e is not mentioned, it hardly matters. We should learn it as the derivative of log x equal to 1 upon x. When no base is given, we always put the base is e. And also one more result related with here. Now the derivative of log x with the base e. Here the base is e. Here with the base a. Derivative of log of x with the base a is equal to 1 upon x into log of e with the base a. Just see the difference between these two results. The derivative of log x or the derivative of log x with the base e is equal to 1 upon x. In generally 95% question we are using this result. The derivative of log x equal to 1 upon x. But here see the difference. The derivative of log x with the base a is equal to, where a is any constant and its value is always greater than 0. Then the derivative of log x with the base a equal to 1 upon x into log of e with the base a. Just see these 3 or 4 are the new result that you are doing in the 12th class. Let me repeat it again. The derivative of e raised to power x equal to e raised to power x. Here the derivative of a raised to power x, it is always a greater than 0. For this, the derivative of a raised to power x is a raised to power x into log a. Then the derivative of log of x equal to 1 upon x. Then the derivative of log of x with the base a equal to 1 upon x log of e with the base a. Now let us recall the theorems that we have done in the 11th class also. The derivative of a constant is always equal to 0. The derivative of a function multiplied by any constant quantity is equal to this constant c as it is, and derivative of the given remaining function, the derivative of f of x. But when the constant is independent, it is not multiplied with any function, then the derivative of constant is equal to 0. But whenever constant term is multiplied by any function, then its derivative will be constant as it is, derivative of fx. Then here the derivative of sum or the difference of two functions. Here u and v are the function of x. Then the derivative of sum or the difference of two functions, the derivative of first function plus minus the derivative of second function. If the plus sign is there, here should be plus. If the minus sign is there, here should be minus. Then the product rule, the derivative of the product of two functions. It is what? First function as it is derivative of second plus second as it is derivative of first. See it again. The derivative of product of two functions. Suppose the function are u and v. Then the first function as it is derivative of second plus second function as it is derivative of the first. Similarly, it is the quotient rule. The derivative of u upon v when the function is given in the form of quotient. Then the derivative of u upon v is equal to v square. V as it is means second function as it is, v into derivative of du by dx minus u as it is derivative of dv by dx. Let me explain it again. The derivative of u upon v, this is known as the quotient rule. V square as it is v into du by dx minus u into dv by dx. Now these results we have to use in our questions. Now here let me see the questions. See here we have to differentiate this function. Now here either we can apply here the quotient rule, but when the number of terms in the numerator is greater than the number of terms in the denominator, or moreover we can say the numerator has so many terms but the denominator has only one term, we can easily separate the terms and collect the powers. Now it can be written as, we have suppose let this given function is y. Let y equal to x square plus x plus 1 upon under root x. Now we can separate it. It can be written as x raised to power 2 minus 1 by 2, 3 by 2 plus x divided by under root x plus x raised to power 1 by 2 plus 1 upon under root x give us x raised to power minus 1 by 2. We are just separating all the terms and collecting the powers of numerator and denominator. It becomes x raised to power 3 by 2 plus x raised to power 1 by 2 plus x raised to power minus 1 by 2. We have simplified our function. Now we have to find out its derivative. Derivative means dy by dx is equal to, first we are using here x raised to power n. 3 by 2 as it is 3 by 2 into x raised to power 3 by 2 minus 1. It will be 1 by 2 plus 1 by 2 as it here x raised to power 1 by 2 minus 1 plus again x raised to power minus 1 by 2 minus 1 by 2 will be here into x raised to power minus 1 by 2 minus 1. In all we have used the result x raised to power n. Now simplifying it can be written as, first term is what? 3 by 2 x raised to power 1 by 2 plus 1 by 2 x raised to power minus 1 by 2 plus minus 1 by 2 into x raised to power minus 3 by 2. It can also be written as 3 by 2, 3 upon 2 under root x plus 1 upon 2 under root x minus 1 upon 2 into x under root x. You can also write the answer in this form. So theta here x raised to power 1 by 2 can be written as under root x power. X raised to power minus 1 by 2 can be written as 1 by under root x. X raised to power minus 3 by 2 can be written as 1 upon x under root x. Now let us see the similar question. We have to differentiate this. Again, this can be easily multiplied. We can multiply it here. We can collect the power. When you multiply it, it becomes what? 2 into x raised to power 3 by 2 plus 3 into x raised to power 1 by 2. Now we can easily differentiate by using the same result. Differentiating it, dy by dx is equal to 2 into 3 by 2 here, x raised to power 3 by 2 minus 1, 1 by 2 plus 3 as it is, 1 by 2 power here into x raised to power 1 by 2 minus 1. It becomes what? 2 cancel with 2. It is what? 3 under root x plus 3 by 2 x raised to power minus 1 by 2 can be written as 1 upon under root x. Again simplifying here because the power are in the same form, you can easily collect the terms. Now taking LCM, you can simplify and get your answer. So answer will be here 3 into 2x plus 1 upon 2 under root x. These are the very simple question on the differentiation, but they can be asked in the 1 marks question. Let us see now the another question. We have to find out the derivative of this function secant x plus tan x upon secant x minus tan x. Let we denote it by y. It means dy by dx. Now we have to apply here what? The quotient rule. It means u upon v. Now here it is what? Secant x minus tan x whole square. Now the second function as it is derivative of first function minus first function as it is into derivative of the second. If we are taking this the first function, this is the second function. Then here again it here second function in the denominator, the whole square of the second function. Then second as it is derivative of first minus first as it is into derivative of second. Now differentiating here, we are getting here secant x minus tan x as it is. Now the derivative of this function. Now we know the derivative of secant x is secant x into tan x plus the derivative of tan x is secant square x minus this expression as it is. Now the derivative of this again, the derivative of secant x is secant x into tan x minus as it is. Now the derivative of tan x is secant square x. Have you understood it? Now let us continue it here. Now again this expression secant x minus tan x as it is. Now we can take secant x common here. So it can be written as secant x into tan x plus secant x minus again secant x plus tan x as it is. Again secant x is common here. It can be written as what? Secant x common. We left with here tan x minus secant x. Now again simplifying it here. Secant x. Now here this secant x can be written as this secant x can be written as here. Now we are using here secant x minus tan x again secant x plus tan x. It can be written as here a plus b into a minus b. This secant x as it is. Now a minus b into a plus b give us a square minus b square. So it can be written as secant square x minus tan square x. Again minus secant x will put it here. Again a plus b into a minus b. This is our what? A minus b. This is our a plus b. Again it can be written as tan square x minus secant square x. Is it clear? Now here again simplifying it. Now we know secant square x minus tan square x is 1. Now putting here secant x as it is. Now the value of this is 1 minus again tan square x minus secant square x. We can take minus common, or it can be written as then secant square x minus tan square x. It is what? Minus 1. Then simplifying it in the numerator, we are getting secant x plus secant x is 2 secant x. Denominator secant x minus tan x whole square as it is. See the question again. The question is we have to find out the derivative of this. Now here what we have to do, we have to apply the quotient rule. It means u upon v, or it can be first function, it will be the second function. Now its derivative is the square of the second function in the denominator. Second function as it is derivative of first minus first as it is derivative of the second. Then we differentiate one by one. Now this remain as it is, secant x minus tan x as it is. Now here that we have to find out the derivative of this. It is a sum of two functions. The derivative of secant x is secant x into tan x plus the derivative of tan x is secant square x minus this bracket as it is. Now the derivative of this one, the derivative of secant x is secant x into tan x minus the derivative of tan x is secant square x. Now we are simplifying here numerator. Now this expression as it is, now from this we can take secant x common and write the terms inside tan x plus secant x. Again minus this expression as it is, again taking secant x common here, it can be written as tan x minus secant x. Now we are using this secant x. Now this bracket is multiplied by this. Then secant x as it is a plus b into a minus b, a square minus b square. Minus, again this is the multiplication. We can put secant x here. Then again using a minus b into a plus b, a square minus b square. Now we are using, we know secant square x minus tan square x is 1. Here it is tan square x minus secant square x. Either you can take minus common or you can put it equal to minus 1. Simplifying, you are getting here, sorry, 2 secant x upon secant x minus tan x whole square. This question can be asked in 4 marks question also, or it may be in 2 marks also. And further we will do this question by a very simple method when you know how to differentiate by the chain rule or some other result.